First of all, welcome everybody that's joining. I'm not sure if you've had the chance to attend any of the MLOPs events that we've hosted. This is actually the second one that we've done for the Bay Area. So welcome all to those who are perhaps not familiar and joining this platform for the first time. And for those who have attended the last one, welcome back. First of all, can everybody hear me? I'm just gonna open up the chat here. I get a thumbs up from Adam. Thank you, Adam. Yeah, so perfect. This chat here, feel free to shoot in. Thanks, Parshad. Feel free to shoot in some questions you have throughout the session. And before I kick things off and give Adam his intro, I just want to mention a couple housekeeping items. For those who haven't been familiar or haven't attended any of these events, what we do is we host the workshops here on Zoom, and then tomorrow on Hopin, we'll have the sessions as well. They're designed for them to be interactive, so I'll mention this tomorrow, but I guess the amount of benefit and usefulness you find in these sessions is kind of directly proportional to the questions that you're willing to ask. And everybody's at a different sort of area of their journey, right? So not everybody's all the way in, fully familiar. Some are just starting and some are in the middle. So feel free to ask those questions specifically if you're not sure. That's okay. It's an open environment here where we welcome all of your input and questions. And Adam's here as a specialist who's very much equipped to help you out. For those who are joining tomorrow, as I mentioned, it will be on the platform for Hopin, so look out for that. We have one or two more workshops today as well. So if you're joining those, you will see Faraz, and then I'll be tuned in again in the afternoon for one of those longer form sessions. Other thing I wanted to mention is if you go onto the website, torontomachineLearning.com, that's our annual summit. There's going to be a lot of really interesting content. I think 25 workshops, 65 speakers. You could get those as they're being released. We will have the director of AI for various companies, Apple, LinkedIn, Facebook, amongst others. And the conversations we're starting to have are what are the most interesting or helpful bits of information based on their experience that they could lend to our community. So not just those big fan companies as well as some of the smaller mid-sized ones as well. Same thing, it's how can we disseminate some of the information and experience that they have so that the community can benefit and put more models into successful production environments. So anyways, that's just a little bit of housekeeping. As I mentioned, Adam will be answering questions towards the end, at the end of the demo. But first of all, if you're not familiar with Adam, he's a 20-year vet of data and software systems integration. He spent the last decade helping the world's largest firms integrate their data with Hadoop and scale their business capabilities with application networks. Adam now leverages all the skills to help those self-same industry giants to industrialize AI and analytics with Dataiku. And Dataiku has been a really important partner with us throughout this past year and throughout some of the MLOps events. So we're really happy to have Adam here and obviously Dataiku as well. So Adam, you should have full steer with screen control. I'm going to turn off my mic and video here and let you take over. And again, for those who are just tuning in, welcome. And if you have any questions, put them in the chat and Adam can get to those very shortly, okay? Adam, thank you so much and over to you.
Great, thanks all. Yeah, so as we said, I'm Adam Gugliciello. I work in solution engineering for Dataiku. And I'm very glad to be here with you all today. For those of you who aren't familiar with Dataiku, we produce a software platform that enables teams to centralize and collaborate on their data and analytics projects across the entire end-to-end lifecycle. I will not belabor the entire end-to-end lifecycle. We will instead be focused sort of at the back half of that. For those of you who aren't familiar with solution engineering, it means that I help our customers adopt our solution and start their journey to what we refer to affectionately as everyday AI. As suggested, my background is one of systems engineering and real-time integration. So I most recently was at MuleSoft, really performing real-time microservice integration of data and services. Before that, I was at Datamere doing big data analytics. And sort of my through line on all of this is traditionally machine learning and advanced analytics platforms tend to produce an awful lot of reports articles in CIO magazine, and there's a pretty big gap between the interesting prototyping and report creation, machine learning analytics, and things like sales target selection, and meaningfully automating and operating the business. And so that is sort of my through line on trying to tie machine learning, AI, and advanced analytics capabilities into automation and operating the business in the same fashion. So today we're going to speak about really how folks can think about data science teams closing the gap between prototyping and production. So we're going to, like as I said, we're going to focus on the back half of the machine learning and advanced analytics pipeline. I'm going to talk, at a high level to sort of level set how I'm thinking about machine learning operations, key concepts and considerations, who does what and when, and what are sort of some of the competing concerns for players in an MLOps cycle. What are some of the things they need to be thinking about from a standpoint of deployment, monitoring, and management? And I will try to keep this as agnostic as possible, but I will be switching into demo in a couple of places. And so obviously I'm going to be demoing the tool that I work with. So I'll be showing some of Dataiku's capabilities around streamlining the machine learning and operations processes that are associated with that. So to that effect, MLOps is a broad and conceptual topic. As in the interest of level setting, I'm using this relatively simple definition to describe what I mean when I say it, which is processes and tools that allow organizations to safely and efficiently scale the use of machine learning in production environments. And it's really a fluid dance and a balance between governance, auditability, and controllability, which is what IT operations very much wants, and self-service, and the ability to, meaningfully do exploratory and prototypical work on the behalf of the data science teams, with the shared goal of putting high quality model systems into production, and importantly, continuously keeping them running, and continuously ensuring that the output of models is still aligned with the intention of the folks who built it in the first place. All of this is in an efficient and controlled manner as possible. So that's the level set. That's sort of where we're coming from when we're thinking about MLOps at Dataiku. And so good means different things to different folks. Each function has different concerns when it comes to what they consider a well-performing model. You've got your data scientists who are, is the model performant? Is it accurate still? Is it degrading? Why is it degrading? Does the pipeline that I built in the first place when I was developing features and functions still operating in the fashion that I expect it to, or has the data started to drift? If the data in the pipeline is fine, does that actually resemble real world evidence? You've got your IT ops folks who are much more concerned about the care and feeding, right? Is this thing up? Is it healthy? Is it responding in a reasonable amount of time when I'm dealing with real-time integrations with machine learning models for things like event handling or IoT tuning? Is it consuming my entire K8s cluster and continues to scale out horizontally in a way that suggests that perhaps it needs better tuning? We've got the business owners who just want to know, like, is it affecting the business, right? Like, what is the ROI on operating this model, continuing to monitor and measure this model? Are my downstream consumers consuming this, right? Like, is it a sales targeting or a next best action model? And are my sales folks trusting that model enough or understanding enough of what it's doing to adopt that in their day-to-day? And then I've got risk managers who are very much concerned with, like, reputational or regulatory risk associated with model biases, especially when you're talking about heavily regulated industries like the FS&I, financial services and insurance, who have mandates coming down from the likes of the FDIC saying that like your creditworthiness models cannot be biased, and there are very large fines if you fail to prove that, and you must be able to both document and reproduce those results and explain to regulators who are not associated with the original training what you did to prepare the model, what you did to address bias in the data or in the model itself. And all of that needs to be meaningfully versioned, needs to be associated with what's in production, and you need to all of the sort of access control and sanity measures around ensuring that the folks who are developing that model are the right folks with the right training, and that the folks who are operating that model are the right folks with the right training. I've got some slides on that near the back that I'll talk a little bit more around the sort of racy chart that's associated with that. But generally speaking, and this is a pretty big generalization, but when folks are thinking about machine learning, they are thinking about this piece of it, right? The organizations start their AI and machine learning journeys, and the data scientist does all the heavy lifting across the entire life cycle, from accessing sample data and acquiring data in the first place, doing the data domestication and transformation to get the data in a form where you can use it for anything. They then train and evaluate the models. They do a bunch of experiments. They need to track their own experiments in a sane fashion. And then deployment happens. And in many cases, the data scientists themselves are associated with at least getting the initial deployment of prototype up. But in many cases, especially as you sort of move down the journey, once that proof of concept or prototype is proven and it's accepted by the business, the code gets thrown over the wall. You get the data scientist who wrote a whole bunch of cool Python, shows up with a pickle file and tries to hand that to an IT operations organization that knows how to run a bunch of Java services, and really doesn't have a great idea about what to do with both the sort of feature preparation and actual model execution that's been handed to them. And in many cases, it winds up being sort of fully re-engineered. All of the project logic, all of the data operations that went into feature development. There's often, an assertion that, like, in order to comply with our operations model, especially when we're dealing with our cloud infrastructure providers, like, we have to think about these things as autonomous, loosely coupled services that are running in K8s and our Kubernetes environment, and we need both east-west, north-south protection, and like there's this whole thing that sort of emerges at the end when the sort of software delivery operations practices meets the prototypical data science practice. And so the first few projects generally make it into flight or operationalized happens because the data scientist is the on-call expert. Right, like it winds up being a sort of close collaboration between IT ops and data science, and even the operations becomes a somewhat bespoke operation. And then, that works for like 3 projects, and then it very quickly starts to break down as you go, up in order of magnitude from 3 to 30 or from 30 to 300. The level of dependency between the data science functions becomes unsustainable. They often don't have the domain expertise to really be sort of thinking about SecOps, DevOps, and CI/CD in a way that is compatible with IT operations. And you really need something more systematic. So thinking about machine learning like this really sort of misses the forest for the trees. The full process is much more complicated. It's an iterative process where the tail end of this life cycle are full-time functions with their own teams in larger organizations that are providing the ability to manage both batch and real-time processes in a sane fashion. And then handing the consumption of the work that's being deployed off to, in many cases, subject matter experts or domain users outside of both the data science and IT operations organization, where those models meet the road, where the rubber of those models meets the road, that is the sales team or the manufacturing organization or the marketing teams that are concerned with actually adopting those models, learning from them, scaling their own organizations from the benefit of those models, and being able to manage the consumption of those, which then feeds back into the top of the funnel as, okay, great. We've seen some great outcomes from our services organization, from our manufacturing organization, from our whatever. We want to build on those successes. We want to adapt the wins that we've had in things like process control, and we start the experimentation and operationalization cycle over again. And so that flywheel effect, ideally, is not introducing friction every time you get to operationalize and deploy and manage, learn, and scale, and so enables the organization to move faster and sort of stand on the shoulders of their giants. And what we often find is, as you grow, data engineers handle access and low-level ETL. The data source level, they're involved in the sort of acquisition and exploration. You've got your data scientists focusing the majority of their time on the experimentation, the piece of the puzzle that they love best. And then IT ops sort of shows up later and is being required to nail that all together into an established MLOPs framework to deploy and maintain the system over time. You really need a separation of concerns, but you need not just, you need all of that sort of working in concert. So like I said, focus on the back half of this. For that last leg where operation engineers take over, it's not to say that data engineers and scientists never come back into the loop. If something changes, something goes wrong, when alerting starts to inform you that models or data have started to drift, those folks need to come back in and ensure that they're sort of, retuning, redeveloping in that experiment phase and developing a new version. But the more self-sufficient the ops team is to manage that project in production, the better. And there's many reasons why the separation of concerns is so important, but there's a couple of basic ones, right? It's a matter of bandwidth. Data scientists generally, the open requests for data scientists on teams roughly outstrips the available folks who could fill those roles by 3x. So roughly 3 times the open jobs for data scientists. So if you're asking them to do ops on models, you never get this flywheel effect. They get stuck in operationalize and deploy, and they never are able to hand that off. The second reason is really know-how, right? Good designers aren't the best implementers. My father was a great mechanic. He'd be a terrible car designer. And generally speaking, great designers aren't good mechanics. To use the energy and use a different analogy, you probably wouldn't ask the person who's designed my solar plant to hang wires on the poles outside my house. And the third piece is really risk management, and this comes back to the governance, control, and audit around especially production models that are running in real time. As AI criticality increases, and so to the sort of half-life of decisions being made by AL decreases, the need to have rigorous segregation of duties and process oversight for governance purposes is paramount. So we at Dataiku think about that as really a collection of deployment and monitoring capabilities. It is folly to focus on machine learning operations, which independent of reliable and robust data operations. It's critical for the entire system to run smoothly. A machine learning algorithm by itself is largely useless. Like a brain without the data that is its lifeblood and the skeleton and muscles that actually execute the brain's decisions, it sort of turns into, like I said, those reports that wind up in CIO magazine. Both the data pipeline and the model have to be operationalized for the system to function. And even with a robust data pipeline, the truth on the ground and the data is likely to start to change as soon as the organization changes its behavior. So as soon as like you start to actually make decisions differently based on the output of a model, you change the ground truth, and you need to be evaluating how that ground truth is changing this model. And especially with things like preventative maintenance models, like it very much becomes a sort of bubble in the carpet, where every time you push it down, it comes up somewhere else. That really becomes an iterative process. That means that you must be both automating detection of model and data and model drift, and ensuring that that is fed back to the folks who are most concerned with whether or not this model is still performing the business function that it was developed for. So, what does that mean? So, this is Dataiku. Here I can see a relatively simple and relatively modest machine learning model. At a glance, I can see a bunch of things about this as a sort of trained Dataiku operator. I can see that this model is mostly concerning itself with data sets coming from Snowflake. It's doing a handful of data preparation steps to clean this data, aggregate this data, join this data, and it's materializing it into new data sets along the way. At some point, it's taking one of these data sets and it is training a new model. That model needs to be meaningfully analyzed from a standpoint of its overall quality, the set of experiments, and we need to meaningfully monitor drift in that, and set up checks and unit tests sort of throughout this model and to ensure that this whole thing is making sense. So this is the sort of thing that a data scientist might create, right? They might do a bunch of data domestication. They might do some training of a model. They might write some code and associate that with that flow, and then sort of try to hand this whole thing off for operation and deployment. And so, as somebody who is thinking about, how do I operationalize and deploy this, I'm going to be, the first thing I'm going to say is, all right, I bundled this application. I was able to package the set of this application as V1. Here's my commit log for the set of changes that I've made to it. Now what? Right. And as somebody who's sort of trying to accept this bundle and maybe promote this bundle, including all of the batch processes and potentially real-time processes on this, the first thing I'm going to say to them is, do you have data quality and data sanity checks built into your flow? And ideally, they can come in and take a look at the active model here across all of my my models as I'm doing things like a data drift analytic and automation, which I'll touch on in a second. And I can take a look at the analyses here. I can take a look at the model, and I can say, what metrics am I measuring? What checks have I created? And I want to do things like ensure that my model hasn't started to drift too much from a standpoint of the area under the rock curve. To say, if my rock check falls below 0.65, start warning people, this model's starting to underfit. If my model starts to get above 0.9, it's starting to overfit. Regardless, this model needs retraining and reanalysis. I want to be able to check the sanity of this model against the data that's coming in at any point, and I need to develop that as a series of tests, and I need to be able to ensure that I've created meaningful process to ensure that my data scientists are creating those sanity checks during their development. I can then deploy this whole thing, right? I've created that bundle. I assume they come in, they've built checks, and they can build some documentation and they can communicate that to me. And I want to be able to deploy this to my location for my operations, right? And start thinking about like a real CI/CD pipeline where I can take dev, I can automatically package and deploy these things with all of the rules around ensuring that this data is, that this code hasn't changed in an inappropriate way, that my sanity hasn't changed in an appropriate way, and I can deploy that to that version to some demo infrastructure in this case for operation on dev, UAT, production, so that the data pipelines that are associated with training this model, scoring the data out of this model, is all sort of operated somewhere else in a hands-off fashion from the folks that are concerned with that. They also need to be able to set up rules for refreshing this data. They need to be able to create scenarios that are either a set of steps or a Python script that allow them to ensure that when my data needs a change, whether that's because new data has happened, whether that's because my subsidiary data set has changed, or simply on a time-based trigger reporting this to my favorite collaboration tool. Do I want this to rebuild all of the data that runs up to my training set? I want them to retrain my model if my model is sort of on some periodicity, and I want to run all of the checks on my model on the latest version. And if that succeeds, I potentially want to lift that as a real-time API service that I am going to deliver into my Kubernetes cluster to serve the business in a real operation. All of these steps for sort of doing the set of data propagation steps, real-time deployment, essentially a set of tests about that, as well as monitoring for how these things are running and the overall sanity of my jobs over time, is all sort of crucial to creating essentially a CI/CD pipeline for the likes of a machine learning and data ops pipeline. The last thing I really need to be able to do is take one of these assets and produce that into an API. So I need to be able to create a new service from this so that the work that I'm doing Bay Area is accessible to the business. This is really where the rubber meets the road from a standpoint of this model that I've created that's training, that's being trained on my stack of data. How do I enrich this from data sets? Maybe I need to be able to look up my customer information rather than tie this directly in to get some information about them. And I want to be able to generate a suite of test queries from this to ensure that my data is correctly prepared and that this data set is sane. Publish this whole thing to Elastic Kubernetes on your favorite cloud provider or on premises, so that I can both sanity check the quality of this thing as well as tie my favorite algorithms directly into this work. I'll come back to some of the questions I'm seeing coming up. I'll return to this demo, but I want to sort of finish the thought here, which is right. Need to monitor these need to automate the data and lifecycle, need to be able to package the whole thing up and ensure the deployment health is sane, ensure that it's responding to that data set, ensure that it's scalable horizontally in a sane fashion for both real-time and batch use cases for preparing this data, preparing features and feature stores, and lifting the whole thing together into really a hands-off, lights-out production pipeline that goes from the sort of prototypical design of the data flow through training, through evaluation and scoring, to a push button automatable pipeline for lifting that data, that machine learning model, and potentially the services and scoring of data sets into higher order environments without requiring any redesign. After I've got that up, there's a whole other thing that happens, which is really, uptime and quality aren't the end of the journey. They're an enabler for the organization to begin to really depend and rely on the model. And data pipelines being operated is all sort of part and parcel. The flywheel really starts turning when the organization can learn to trust these models, and that requires monitoring that the models in play are performing as intended, not only from an uptime standpoint, and not only looking at, is my automation monitoring telling me that this job is running every night and that my data sets are being correctly populated and my models are being retrained, but are they starting to treat subpopulations differently? How do I ensure that this model is ethical? And how do I convince the folks in my organization to understand what's happening in that model, adopt it, and trust it? And that really comes from being able to white box these APIs. And so, that comes into really becomes something that you want the same platform to be providing. So in addition to providing sort of experiment tracking on my API, on my models rather, and being able to see what did we do when we were training this model from a standpoint of feature generation, what did we do to do things like allow custom pre-processing with Python code, or choose my own specific algorithms, or add my own custom algorithms. How, once I have trained this model, and once I am using this to score this data set, how do I come to understand how is this model behaving? How is this model performing? How is this model performing over time? And how is it compared to its siblings that we've continued to train? It becomes an exercise in really being able to interpret this model sanely. So this is a trained model. I can, very quickly see, what did we do for data preparation? Not much. What did we do for feature pre-processing? What have we done to sort of understand which algorithms we're executing? What meta parameters did we choose? If I'm a data scientist, I can be looking at the confusion matrix or the lift charts or the ROC curve for this model. But importantly, for folks who aren't that, I need to be able to understand, what are the most interesting features of this model? What are the variable importances? And I need to be able to produce some analytics and some interactive scoring that I can communicate to my folks who are actually trying to consume this model. In this case, a sales targeting model that's telling me the likelihood of a given customer to be a high revenue spender with us. What are the things that I want to tweak in order to see how this model is going to change, right? What do I think is going to affect these things if I change their birth date? Is it make them more or less likely to purchase from us if I change their age, if I change the age of their first order? At what point do they become someone that we are predicting that will purchase from us? And I can publish this all to a dashboard so that as somebody who is consuming this model can come here, they can see, what do we think about this data, and how's this data landing from an aggregate, and how's the model performing on individual records? What's the sanity of this model, and how do I interactively score this model in a way that allows my folks to really understand what's happening in this model in the same fashion. In addition to that, I can meaningfully understand, as somebody who is potentially in the risk and regulatory teams, not just how is this model trained, but how is it currently fair, right? So I can do some bias analysis on this to say, is this model biased to assume that, for instance, women are not big spenders with us? And is that an issue with the data, with our product set, with how we're going to market? What is it about our past performance that has taught this model that people with a gender female here are slightly less likely to be high value targets for us, for our sales team? And I also need to be able to meaningfully craft an analysis of how the data that we have trained this against compares to the data that we're scoring this against, and potentially trend that over time to see, how has this data drifted over months or weeks? How sane is this data with regards to the expectations and input from the test data set over the input data set? When is it time to start meaningfully retraining this model or revisiting the feature-free processing or data analyses about this, so that in addition to sort of checking the sanity of the model, I need to check the sanity of assumptions being made in the data pipeline that's flowing into it, as well as compare that to, the ground truth from a standpoint of, evaluating this model in a sane fashion, so that I can ensure that, as I'm passing real world data into this, I can check all the assumptions of that model. All of this really sort of lending itself towards ensuring that the organization can sanely adopt this thing, can meaningfully understand, what did we do to actually describe the set of changes to this model, right? Or the data sets that are feeding into this as I'm preparing this set of data, and allowing the folks who are writing code to be able to promote their data sets, their data preparation, model execution, general notebook type stuff, to higher order environments without requiring a huge uplift from my engineering teams in the, with regards to where is this data, where is a similar representation of this data, what is the stack of libraries that we're using to interact with this data. And when we look at sort of code notebooks or IDEs, ensuring that when I'm working in a given kernel, that kernel is something that I can package as a Kubernetes image and ship to a bunch of horizontally scalable containers without requiring a bunch of effort on behalf of my engineering teams, so that they can ensure that the ad hoc code-driven work that you're doing, or the click-through AutoML or data preparation work, can all be lifted together into a deployable archive. So what that winds up looking like, right, is that sort of virtuous cycle, turning from managing and learning and scaling and ensuring that my data set is sane, and the assumptions we made about my data set are sane, feeding back into, well, ABC model on my sales team is working very well to target for this set of products. Let's hand this over to our human health division or our pets health division or my subprime credit organization, and they can take similar models and apply that to new and similar data sets in a fashion that allows you to expand this across the business and go on. So, as I mentioned earlier, there's a set of related but discrete drivers for governance and operations. Where governance is concerned with things like proving to regulators that only trained and certified folks are accessing or updating models or data pipelines. IT operations leverage that same set of access control rules to ensure that people like me are not making changes in production. That there's no data scientists running or tweaking models someplace where they shouldn't be. They're not causing downtime. Their pager duties aren't going off. Like, that's what IT ops is very much concerned about. Whereas, your IT governance folks are about ensuring that they can communicate to regulators and risk folks in a sane fashion. That continues through the requirement stack, where regulatory and risk are looking at showing executives that there's no drift or no bias in their models, whereas the IT operators are using audit trails to ensure that nobody has made changes and to do root cause analysis when things break. Likewise, your ML governance folks are thinking about failover and disaster recovery plans, whereas the IT operators are looking at that same set of controls, auditability, separation of concerns, redeployability, and horizontal scaling as not so much an downtime preventer, or not so much a disaster recovery issue, so much as regulatory compliance and SLA targets to ensure that nothing we've done here, it can't be automatically redeployed to a new zone, a new AZ, a new set of boxes, or even a whole new cloud provider. We want to make sure that the work that we have done is discrete from that, the set of environments that we did the development against in the first place. So, some key takeaways before I switch to Q&A. It's a lot about people and processes, but it's also important that you're thinking about this in a platform kind of way that is really not divorcing ML ops from data ops, right? You need to be able to reproduce the same data pipeline that data was trained on, that features are being generated on, but you need to do so in a way that can be meaningfully understood, can be monitored, not just from an uptime and health check, but from a drift, from a model and data drift, from a bias and from a creeping bias standpoint, and from a place of sort of understanding that the folks who are making changes in prototype are not doing anything that can't be reproduced in higher order environments, UAT production, and that the folks who have access to those don't necessarily need to understand the work that went into the prototype in order to be able to deploy that, which means you don't have to rebuild and re-engineer. So, it's really, as I said, a delicate balance between data science and machine learning governance and ML ops, as well as machine learning adoption and understanding over the life cycle of a model that works together to scale your ability to adopt these things over time. So we have a book out that talks about this in a heck of a lot more detail. So we have developed a really sort of deep dive on how design and development interacts with deployment. What are the sort of crucial drivers you need to be thinking about when you're thinking about deployment? What are the things you need to be monitoring for? How do you tie that back into iteration and versioning? And what are some of the sort of primary governance drivers that folks are thinking about? So the book introduces really those key concepts. It's really aimed at driving real business change. And we have an expo booth. If you have additional questions after I finish Q&A, or you want to speak to somebody about the Dataiku product. So that is all that. So I'll go through the questions. Are you going to get the slides afterwards? I'm going to point that at Toronto Machine Learning, but I think the answer is yes. I think there's also a recording of this talk coming. Whether assess stage in this slide gets inputs from deployments. So the question you're asking me there is here on assess. Yeah, so yes. I mean, ideally, the assess there is sort of part and parcel of, well, there's sort of two flows there, right? There's the assessment during experimentation, right? So while I am building my model, I score my model, I do my train and test split, I run this against some known data, and I generally come up with a candidate for something that I wanted to put into production. That then goes into production and gets operationalized, and we try again in a month, in 6 months, in a year, and we start to account for seasonality in that data. Like at some point that becomes this model has started to drift, this data has started to drift, and you sort of start to treat it as developing the new version of whatever that original model was in this sort of, in this cycle. So yes and no. The long and the short is that first experimentation before the first deploy rarely has enough real world evidence to meaningfully assess the sanity of the model longitudinally. Amar asked me, is this service available in all public clouds, AWS, GCP, Azure's the third one you missed? Yes, so we are agnostic to your cloud provider at Dataiku. Fundamentally what we are doing in a flow here is we are very often pushing this down to execute against the engine that makes sense. So here I've got a bunch of snowflakes. So a lot of this is going to be pushed down to run in Snowflake because that's where the data lives, and you always get a benefit from not moving that data. And of course, if it's Snowflake under the hood, we'll use Snowflake. But as I'm looking at things like pushing down to use SageMaker as my analytics, or I've got a bunch of S3 here, the set of engines that I'm going to be using to execute this might be being handed off to Spark, might be being containerized for execution at any point. And that's part of the big reason that you can really take advantage of Dataiku is we can lift big chunks of this and drop them into whatever engine makes sense to execute this based on the data. We can also containerize data elements like this classification or clustering machine learning. Classification or regression machine learning models, and execute those horizontally on Spark on K8s or on Python on K8s or on R on K8s without you necessarily needing to do a bunch of work. Like we're automatically managing the interaction with the cluster on their behalf in a way that can also be snapped off and switched to higher order environments as you move from dev to UAT to production. You need to be able to control how we're choreographing this whole bundle of data set as we move up. Adrian asks, if I have a machine learning pipeline, Python already done with a pre-trained model, can you reuse making this model usable in Dataiku? So yes and no. So I've got sort of two answers there. One is current state. I can lift any of my models into training, right? So when I am training a data set, and I come back here and I want to train this model, and maybe I've got a bunch of pipeline stuff that I'm doing directly in here. We can let you choose, from our quick prototyping models, interpretable models, high performance models. You can add your own scikit-learn classifiers into this as well if you want to. We can also push these to things like H2O or MLlib to do these things in parallel, which sort of greatly reduces the number of available models because you start to get only the ones that are parallelizable on top of MLlib. But yeah, I can always tweak these models, snap them in as a custom Python, or here I've got a plugin as part of our plugin system that's doing the light gradient booster as part of my set of classifiers when I design this model as part of the prototyping phase. We then are going to train that across all of these and evaluate which of these models is working the best. We're going to do a hyperparameter search. If we have a Kubernetes cluster like EKS or AKS or some other one that you're operating, under the hood, we will push that work to do hyperparameter searches in parallel. And then you take a model and you deploy that model to your flow for turning into that sort of scenario for retraining, for reevaluation, for checking the sanity of it. Over time, that becomes something that we're managing automatically for you. So if you're doing it in our framework and you've got a model, you can break chunks of it out and snap that into our AutoML, our experiment tracking, and it will be deployable as part of this flow. That's current state. I'm going to talk about roadmap a little bit here. So safe harbor, make no buying decisions based on products that don't exist yet. We do have an ML flow integration coming soon, the details of which I can't share here. But essentially, any code notebook that is lifting model scoring, model training together that is incorporating the ML flow capabilities will be something we can expose into our flow as this green rhombus and track and be able to do things like generate APIs from and be able to generate documentation from as well. No worries. So that was a little bit of a long walk. That roadmap I just talked about is immediate term. It's sort of due very soon, coming soon to a Dataiku near you. That's my set of questions. So if y'all don't have anything else, I'll give you a 5-minute dividend.
Okay, thank you so much, Adam. That was fantastic. Really great deep dive, and I appreciate how you mixed in some non-platform specific information as well as a good deep dive there on the Dataiku platform. And obviously, thank you so much for Dataiku for all the help and support.
Raj has a question. Can we set up schedule job? And Dataiku. Yes. So we have our own scheduling engine. The development of the scenarios that you saw earlier is absolutely something that we provide. There's always a question like, so I've got this auto-triggered schedule that's running time-based sort of once a day at midnight because I like to live dangerously, and surely nobody else wants batch processes running at midnight. If you don't want to use our scheduler, which is aware of the data and data set changes if I'm dependent on other projects, you can access just about everything I showed you is accessible through our API as well. And so you can tie this into your favorite AutoSys, whatever your favorite automation tool is. You just call a REST endpoint and trigger our scenarios. Yeah. Yes. I already answered that question before you could ask me. So yes, you can use AutoSys to trigger the workflow. Generally speaking, we provide our APIs for both accessing the scenarios, execution, and monitoring as RESTful services, all documented at docs.dataiku.com, or Python endpoints. We provide a Python wrapper, so it makes it a little easier if you're trying to use something like AutoSys, because you can trigger and wait rather than having to poll, because of course RESTful is stateless. Anybody else got anything? Otherwise, I will give you this dividend.
Very good. And what we'll do is just as somebody had mentioned, the videos will be sent. We'll aggregate some of the questions here and some of the resources that were provided. Alex has one more. Let's
Yep.
You have a minute there?
I do. So feature store is an interesting question. And I can wax rhapsodic about it a little bit if you'd like. But when we think about feature store, we're really thinking about feature store as an artifact of this pipeline. So like my order cleaned, my customer labeled data, for instance, might be something I want to lift as a set of features because it's interesting to my data set. I'm doing something IoT that's going to be deeply, a deeply reduced set of features. I need to ensure that the feature store is being populated with current state for the data training. And I need to be able to access that regardless of who wants it. So, as I hinted at earlier, we can create an API here for many of my models. So this creates my cool model, right? And my cool model gets an endpoint that is high revenue, okay? And I can enrich this from a feature store will essentially generate from any of the data sets in this. So if I've got customer labeled information on a SQL data store, I can bundle that into in-memory data sets bundled in here. I can say, I want to look up, do my bidding. I want to look this up. Now, coming out of a microservices background with MuleSoft, feel like the creation of an enrichment inside my endpoint is a monolith. And I hate monoliths. I try to think about these things as loosely coupled services. And so what I would probably do is lift this with our API designer into a new endpoint from any of my services. So this might be my customer feature lookup. And my customer feature lookup is a SQL query or a data set lookup, and it's my customer lookup from my feature store, and I'm going to go get whatever the version is of that data set, either as a SQL data set or customer feature lookup. I want to add an endpoint, and I want to, I'll just go start over. I want to create an API service that is dataset lookup, and dataset lookup is going to use any of the feature stores that I've created before. And at that point, I can say, use any of my data sets, use my customer label data set. The key is going to be customer ID, return, gender, birth date, and age. And now I've got a suite of disconnected services that are each related to the set of materialized transformation data sets that I have produced. And I can essentially get real-time choreographable services that can enrich the data coming in from, say, my Kafka bus, and push that to my API endpoint for scoring my model. without building that all together into dependencies that I don't like in a microservices model. I can also defer to a real feature store if you'd like. So to something like that. The former, where I've got a bunch of disconnected services, feels very much like a service mesh, and is very much aligned with what we were building at MuleSoft around sort of application network. And the latter feels like another cache that I have to manage lifecycle on, and generally speaking, there's really only 3 hard problems in computer science, right? Naming things, cache and validation, dependency hierarchy, and off by 1 errors. Yes, there's an integration with Elation. We're tied pretty tightly to it. They're one of our best partners, and with an Elation server, you can automatically curate data directly into our platform. And yes, it is possible, and I sort of hinted at this earlier, to use SageMaker to do our scoring. We have this SageMaker plugin that lets me push a SageMaker inference to an endpoint, or I can use this to produce the record IO formats that I need for doing scoring and training. And now you get no dividend.
So, okay, and if you have any last minute questions, get them in. I've just mentioned the videos will be shared tomorrow on the session platform on Hopin. Dataiku will also have a booth there, so you can pop in, mention that you'd be interested in reaching them, and they always have some good giveaways too. So I recommend either way, you go in and say hi and just register your interest to the booth there. But that being said, thank you very much everybody for joining. I really appreciate it. Thanks for taking the time. Adam and the team, it was really informative. So I hope you enjoyed it. And for those who are joining here today, and for those actually who didn't make it as well, we'll be sending out all the videos. So just let us edit those. We usually do a little bit of a light editing, and then we'll send those out. So that being said, I think I'm good. I will see those joining our session in the afternoon. Thank you very much, Adam, and thanks everybody for joining. We'll see you again shortly.